Okay, lecture for binomial distribution. So the binomial distribution. So there are many experiments, either exactly or approximately following list of requirements. So I will define 4 points, and many of the random experiment which follows these 4 rules. Okay. So such distributions we call binomial distribution. First one, the experiment consists of a sequence of n smaller experiment called trials, where n is fixed in advance. For example, I will give you an example. If I am tossing coin, a coin. So and So this is a random experiment since it has only 2 possible outcomes, more than 1 possible outcome, head and tail. So this is a random experiment. And for example, if we conduct this random experiment, that means we toss this coin n times. That means the experiment consists of a sequence of n smaller experiment called trials. That means we are doing that experiment n times, and each trial can result in one of the 2 possible outcomes. So the second condition is it must have only 2 possible outcomes. So tossing a coin has only 2 possible outcomes. Therefore, tossing a coin random experiment satisfies these 2 conditions. And third one, the trials are independent. Okay, so that the outcome on any particular trial does not influence the outcome on the other. That means if we toss the coin first time, it may be head or tail. If it is head, it doesn't depends upon the second trial. Second trial may be head or tail. There is no doesn't depends the previous outcome. Previous outcome doesn't depends the next trial. Okay, that means they are independent. And fourth one is the probability of success is constant from trial to trial. That means for each trial, the probability of success is constant. That means if you are taking this example, probability of getting, suppose I am taking success as head and failure is tail. Then the probability of success is 1 by 2 for each trial. So if any random experiment satisfies these 4 conditions, then we say that that random experiment is a binomial experiment. And now we will define what is binomial distribution. So an experiment for which condition 1 and 4 is called a binomial experiment. So what are the conditions for binomial experiment? The uh, conditions are these are the conditions. Okay, so experiment must be conduct n trials, and second one, each trial can result only 2 possible outcomes. So 2 possible outcomes, and success and failure we call success and failure, and trials are independent. And fourth one, probability of success is always constant. Okay, so such experiment is called a binomial experiment. So let us take an example. I'm taking tossing a coin. Okay. So if we tossing tossing a coin n times. Okay. So if I toss a coin, there are 2 possibilities, either head or tail, and each has the probability of getting head is 1 by 2, and probability of getting tail is 1 by 2. So there are only 2 possible outcomes. And if we toss this n times, we will this experiment is a binomial experiment because it satisfies all four conditions. Okay. And another example is for binomial experiment is for example birth of a child, birth of a child, childbirth. So this experiment, so childbirth is either boy or girl, either boy or girl. So there are only two possible outcomes, and it doesn't depend. First boy doesn't depend. Second, that means the doesn't depends upon the next. Right. Okay. So any experiment which satisfies this four condition is called a binomial binomial experiment. Now we will define random variable. So we have a binomial experiment, that means an experiment which satisfies that four conditions. Then we will define a random variable. So the binomial random variable x associated with a binomial experiment consisting of n trials. That means, for example, tossing a coin n times. We are conducting tossing a coin experiment n times. Then x denotes number of trials. That means random variable x is number of s among n trials. That means number of success. So S denote number of success. It's depending upon our experiment. For example, if we take head, getting an head is a success, then getting an x equal to number of heads while conducting this binomial experiment n times. Okay, for example, if n equal to 3, that means we are tossing a coin 3 times. There are 8 possible outcomes for the experiment. Either maybe it's like head, head, head. That means success, success, success. Or maybe success, success, failure, success, failure, success, success, failure, 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 success, success, failure, success, failure, 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 success, failure, failure, failure. So there are how many possible outcomes? 8. Now the probability, okay, so now by definition of x, that is number of success, x of, if I am taking this even, x of number of success, 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 failure. So in this trial there are 2 success. So x of s is 2. Here how many success? 1 success. So x of s ff equal to 1. So now tell me, what are the possible values that x can take? X is number of success. Tell me, what are the possible values that x can take? Anybody? If we toss a coin 3 times, what are the possible values that x can take? Anybody? Anybody? Number of success. So here, how many possible? That means x is number of success. Success means either it may be 0 if f then 0, or it can take 1 success and 2 failure. So 1 and 2 and 3. So x, this random variable can take 3 4 possible outcomes, 0, 1, 2, 3. Okay. So this is a discrete. Now we define, and I have to find what is the PMF. So random variable X, and this PMF depends upon two parameters N and P, number of trials and probability of success, and we denote PMF by BXNP. So for example, if I want X equal to 2, N equal to 3, P equal to 1 by 2, so how many X takes 2, number of success is 2 is this, and this. So the probability is P of getting X equal to 2 is X equal to 2. That means there are two possible, this or this. So how many ways it will happen? 3, choose 2 ways, and what I have to get, this probability is equal to 1 by 2 times 3, and 1 minus 1 by 2 times 1. So that is 3 choose 2 times 1 by 2 raised. So that is Px and P is number of sequence of length n consisting of X success is into probability of any such particular sequence. So here this is like number of sequences. So how many ways you can take 2? That is Px B 2 3 1 by 2 is number of times you can choose is 3 choose 2 into any, that's 2 square into 1 by 2. Okay, so next this Bx and P is, therefore we can define probability distribution function of PMF n choose x p raised to x into 1 minus p all raised to n minus x, where x is 0, 1, 2, etc. up to n, and or 0 otherwise. So this is the binomial PDF of PMF of binomial distribution. So if we have a experiment of length n, then x follows binomial n. We denote binomial np, and its probability distribution function is, or probability mass function is, n choose x e raised to x into 1 minus q raised to. Now we will choose an example. So each of 6 randomly selected cola drinkers is given a class containing cola S and one containing cola F. So there are 6 randomly selected cola drinkers is there. So, and class containing cola S and cola F. That means these 6 randomly selected uh, drinkers can choose either one of the two type of cola, S or F. That means there are only 2 possible outcomes. So if you take one uh, cola drinker, he can choose either S or F, and we are consisting of 6. That means we are conducting it 6 times. So n equal to 6 here, and the classes are identical in appearance except for code on the bottom to identify the column. there is no actual tendency for cola drinkers to prefer one cola to the another. So that means the experiment is independent. So now I am taking success probability P equal to probability of selected individual prefer S. Then its probability is 1 by 2, 0.5. Now I am taking X is number of among the 6 who prefers S. So total X is number of success. That means. Hello, hello. Am I audible? Hello, hello, hello. Now, am I audible now? Anybody? Okay. Okay, let me share my screen. Uh, there is a network problem. Okay, am I audible now? Okay. So, example. So the binomial distribution has a PDF or PMF of the form n choose x p raised to x into 1 minus p all raised to n minus x. So let us discuss this example. Each of these 6 randomly selected cola drinkers is given in a class containing cola S and cola F. So there are two types of colas, S and F, and the glasses are identical in appearance for a code at the bottom to identify the cola. Suppose there is actually no tendency among cola drinkers to prefer one cola over the to the another. That means the selection of cola is independent. The experiment is independent. So, and how many people are there? 6. So n is 6 here, and probability. Okay, p. I am taking p is probability a selected individual prefers S is. So there is no tendency to choose prefer one cola over another. Therefore, the probability of choosing either one of the cola is 1 by 2. That is 0.5. P equal to 0.5. Then 1 minus P is again 0.5. Now X denote, X is I am choosing numbers P. P means probability of success. That is I am choosing the success is individual prefers S. Okay. That is X is number of among the 6 who prefer S. So I will denote X follows binomial 6n P 0.5. Thus, P of X equal to 3 means probability of X equal to 3 means among the number 6 X 3 among the 6 who prefers S, that probability is B 3 6 0.5. By definition here N is 6, 6 choose 3 0.5 all cube into 0.5 all cube. So the answer is, now if the probability that at least 3 prefer S is at least, so that means P of X greater than or equal to 3, right? That is P of X greater than or equal to 3. So that means uh, it will be P of at least 3, X equal to 3 plus P of X equal to 4 plus P of X equal to 5 plus P of X equal to 6. So this total sum. Now if you calculate this, you will get the answer. Okay. So P of X equal to 3, we will have substitute value in the probability distribution PMF, and we can calculate easily. Now the probability that at most one prefers S is P of X less than or equal to 1. Now which is equal to 1 by X equal to 0, Px 6.5. So this is the answer. Now for example, if we want to calculate this, that means P of X equal to 3 plus P of X equal to 4 plus P of X equal to 5 plus P of X equal to 6. This calculation, it will take time. So we will use a table. I have shared that table uh, in your WhatsApp group. So I will show. Next question we will do by using binomial table. In this table, we will give that is if X follows binomial NP, the CDF will be denoted by capital BXNP. So that is equal to actually P of X less than or equal to small x. So the table gives the value of P of X less than or equal to small x. For example, if I want to find out P of X less than or equal to 20, when n equal to 20 and P equal to 0.5, then I can use table with n 20 and P 0.5. The table will give the value of B 20, n is here 20 and P is 0.5. The table will give the probability of this. And if I want to select find P of X equal to 20, not, then also we can use the probability binomial table. We can use this is actually equal to P of X less than or equal to 20 minus P of X less than or equal to 90. So this value we can get from table and this value. So I will show you how to take this value. Okay, so by next example, we will do this problem. So suppose that 20% of all copies of a particular textbook fail a certain binding strength test. Okay, so 20% of all copies of a particular textbook fail a certain binding strength test. So this is a binomial experiment because either it fails binding test, a strength test, or it success. So there are only two possible outcomes. So let x denote number of amongst 15 randomly selected copies that fail. So here our x is number of among 15 randomly selected copies that fail the test. So number of test fails strength test. Number of text copies of text fails strength test. So that is x. Now then x has binomial distribution. Binomial distribution, that means x follows binomial distribution by n 15 and probability is given 20% is fails, so 20% means 0.2. So the probability that at most 8 fail the test is, so what is that? P of at most 8 fails. Therefore P of x, x is number of test fails, number of text fails. So that is equal to P of x less than or equal to 8. So I want to find out this. Okay. So here look at this. Here n equal to 15 and p equal to 0.2. So we can use table. You can use table. In table I will show you that. In table I will show you that. Okay. N equal to 15. N equal to 15. So the binomial table is n equal to 15. Okay, this table, and p equal to 0.2. I want to calculate this. P of x less than or equal to 0.99. Okay, so the answer is, this is the answer. P8. From the table we will get 8 15.2. So the answer is, okay, from here this is 15n and x equal to 8 and this 0.999. And similarly from the next question, exactly 8. So that is p of x equal to 8, p of x less than or equal to 8, and minus p of x less than or equal to 7. So from the table we will get p of x less than or equal to 8 is 0.999 minus p of x less than or equal to 7 is 7 is this 0.996. Okay, so the answer is this. So let me conclude this session by using two exercise problems. Okay, thank you.